And now we're going to deal with semicircle functions. So overall, semicircle functions are denoted by the following equation: y is equal to the square root of 1 minus x squared, also denoted over here, and the domain refers to real numbers between -1 and 1, inclusive to -1 and 1, hence the brackets over here. And then we have non-negative real numbers between 0 and 1 within the range. For we know that the domain refers to the x-axis and the y refers to the range over here. Just need to zoom in for a second. And so, always to keep in mind whenever we're dealing with circles in general, the radius is always going to be 1/2 of the diameter, or you can just put in diameter divided by 2. And that would also give us our range. Just for context and just to be able to help cement the idea further. Let me just zoom out of here. And now, in this case, so if we were to have a positive semicircle, it would be denoted as this. But if we were to have a negative semicircle, it would typically be denoted by this: y is equal to negative square root 1 minus x squared. The negative is typically in the front, and we would have the same range as in distance wise, but in this case it would just be at -1 in this case over here, and it would still have the same domain. So we have 1 and 1 over here. So that's for further context, and then this is also 1 up here. Okay. Now that we got all this stuff out of the way, let's head over to our first practice problem. And now, let's go over our first practice problem. So in our first practice problem, we're given f of x is equal to negative square root 16 minus x squared. And so, what we need to do, in terms of graphing the whole function, we also need to do the following steps. 1, determine the domain and range. And second, find the vertex. Luckily, there's a bit of a hack to this, which I'll showcase soon. So we always know that the domain is going to be equal to x, and range is going to be referring to y. So whenever going our first step, what we need to do is that we can actually do this thing where we can just take out the negative and as well as the square root, and we can just denote 16. Actually, I'm just going to use this different color. We do 16 minus x squared is greater than or equal to 0. And so once we do some algebra over here, negative x squared greater than or equal to -16. And whenever we are divided by -1, to cancel out the negatives, this sign actually flips over. Just what they have, and then finally we square root, so x is going to be less than or equal to 4. And since we're dealing with a semicircle altogether, since we have an x squared inside of a square root, we can actually already attest that we would have a -4 over here. So this would be our domain. Now to get the range, we have a different means to do so. Getting the range means we're focusing on the y-axis in general of how far up and down it will go. And we're also, whenever we figure out what a range is, that's actually where a vertex is going to be located. Because in the context of our semicircle that we have, since we do not have anything inside right next to the x squared, that means that the y-intercept will be at 0. And so when we have that predicament, x would mean at 0. And when we have that case, That means all we need to do, the range being, is going to be 0 less than or equal to y less than or equal to 4 in this case. Since we already determined that x is less than or equal to 4, we can also test that y in of itself would fall under the same circumstances as well. And to better clarify, what I mean in particular is that since we already have our domain already set up between -4 and 4, we can actually plug in values for x to be inside of our equation for f of x is equal to negative square root 16 minus x squared altogether, and then we determine our range. It's a bit of a tip and a bit of a hack that we have over here. So for us to be able to graph this, let's just move this over here. 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Since we have negative to start with, that means that we're going to have a circle that's going to be upside down, and we determine that our range is from 0 to 4, and then our domain is going to be from -4 to 4. So that means we have this point and that point, -4, 4, and then we have -4 all the way to 0. This is how our graph would actually look. And so yes, that is just the first problem that we have. Feel free to take a screenshot of this one, and we'll head over to our second practice problem. And now let's go over our second practice problem. So in our second practice problem, we have g of x is equal to the square root of 25 minus x squared. So remembering our steps that we have, one, we got to determine the domain and range. Domain referring to x, range referring to y. And the second part, determine the vertex. And we always remember a little hack. If we can figure out the range, we can figure out the vertex. You got it. And so let's start off with the first part with figuring out the domain. Let me just zoom out of here so we actually understand. Different color over here. And so whenever we get rid of our square root, we have 25 minus x squared greater than or equal to 0. So we got 25 minus 25 minus x squared greater than or equal to -25. And whenever we divide by -1, this side always flips. So we have x squared greater than or less than 5. And since we are dealing with a semicircle here, this is actually, so a big point I need to highlight right here. So some people may think, oh, what if we were to add, for instance, having an addition right over here, just right here. Well, that's not going to be a semicircle at all. It's going to be a totally different graph. So actually it is denoted by having this minus x squared that really denotes that we're going to have a semicircle overall. Just a bit of a side note as well. But going back to determine our domain is going to be from -5 all the way to 5. So that means we can also have a test that will be -5 to 5. That's how we would denote it. And the range, on the other hand, this is where the magic happens. Since we already know, in particular, since we already figured this part out, and we're dealing with the semicircle, all we got to do between the range of g of x is just going to be 0 greater than or equal to y, and then 0 is less than or equal to y, and then y is less than or equal to 5 overall. That is what our range will be. And since we are dealing with a positive side, this is where we also need to denote more. So we have x, and we have y over here. All inclusive. Whoop. That's not part of it. That's a totally different graph. Anyway, let's just go over here to determine our equation. Actually, I'll go right here. That's better. And so, Drawing it out. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It's going to be pretty easy. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's negative 5. 1, 2, 3, 4, 5. And that's positive 5. And since we were doing a positive, our vertex is going to be at the top since we have 5 all the way at the top over here. So let me just zoom out. And that was our second practice problem. Let's head over to our next function, which will be reciprocal functions. Hey everyone, thank you again for taking time to watch this video. If you found this video helpful, be sure and feel free to please like and subscribe, smash the like button, and ring the bell for any notifications as well. And if you have any other questions, by all means, feel free to put it in the comment section as well. And as always, take care. Cheers. Bye-bye.